Hello everyone, thank you very much for joining me for this fourth lesson where we continue our discussion on primary keys. So we are on track with our observations on JPA and Hibernate, and hopefully you have already learned a lot of things during this playlist. If you are here with me live, remember you have a live chat and you can ask your questions in the live chat. If you are watching the event recorded, you can still follow me on Twitter or X, whatever the name is now, and LinkedIn, and we can I can take your questions for one of the next lessons, or of course answer you in a comment. With that being said, thank you very much again for being here with me, and I'm gonna share my screen and simply continue our discussion quickly, because I know what you're interested in is the topic of today, and this is primary keys. Now, I already started discussing about primary keys in the previous lesson, but we only discussed that an entity needs to mandatory have a primary key. We discussed about the ID annotation, and I told you that regardless of the database management system you use behind the scenes, with JPA is mandatory to have an ID. So even if with some database management systems you can skip the existence of a primary key for a table, that's not possible for an entity. So you'll always have to find either one column or a combination of columns which are unique. So the worst case scenario, I was telling you this also in one of the previous lessons, is that you have all the columns in a unique combination. Of course, it doesn't make sense to have two rows which are equal, definitely. So that's the worst case scenario. But you either have one column which we name simple primary key, or you have two or more columns, eventually even all the columns of the table composed as the ID. And when you have two or more columns, that's what we call a composed primary key. So what I'm teaching you today is two things that I want to discuss. One of them is I would like to show you how to create a custom generator for your IDs. In the previous lesson, I told you how to use the generated value annotation, and I showed you the strategies. I told you about identity, sequence, table, and the latest addition UUID, which comes with one of the latest versions of JPA. But today I will show you also how you can create your own strategy. So that's the first part of today's lesson. The second part of today's lesson is showing you how to create composed primary keys, and we have two possibilities. You'll see one of them is using the ID class annotation. The second one is using an embedded ID. So we will go through these topics, and of course we'll go through them practically as I already got you used with, and you saw that I have already created a project. I have simply copied one of the previous projects. So the only thing it does is declare this entity with three fields, very simple entity. You should already be aware about what these annotations do, what an entity is, and so on. If not, if this is the first time you are here with me, remember this is lesson number 4. So in the previous 3 lessons we've already discussed that, and I won't go through them again. So my recommendation is, if you need a refresher on what all these are, review the first 3 lessons. And also I can remind you that we basically use here the programmatic way of creating a persistent unit. In the first lesson I showed you that you can use an XML file as well, but I have copied the example with the programmatic approach. Anyway, regardless of this, in the end you remember that you get an entity manager factory, and then you can create as many entity managers as you need. Now, so in the previous lesson we discussed about generated value annotation. And you know that we have the 4 generation strategies that we discussed, identity, sequence table, and UUID, and we have already demonstrated those. Now, one of the things that why I want to show you is that you can actually build your own logic for generating the values. So let's say that instead of using an UUID, I want to use a specific logic behind the scenes. I will start by generating UUIDs, but not by simply setting the strategy as I've showed you, just to show you the logic, and then maybe we go through a more complex example. So let's take them step by step. So if you want to create a generic generator, so let me cut this out for the moment. Let's say that we create a separate package here and we call it generators. Okay, and I want to create my own UUID generator, so I will simply name it UUID generator, and I have to implement identifier generator, which you have to be very careful. So this is not part of the JPA specification. This is something that Hibernate provides you. It's not something that JPA provides you. So when you go with dealing with custom ways of generating the primary keys values, you have to be aware that you are using something outside of the specification, which means that if you change, say you will in the future need to change the implementation, the JPA implementation, then you will need to change this as well. Now we know what that the chances for that are. Usually they are very small, probably 0. So I would say this is a skill you would need to learn. Sometimes there are cases, maybe not that often, but cases where you need to deal with the logic of generating the primary key value. So knowing this about the primary keys, I think it's a helpful skill. Now definitely we need to override the abstract methods. The only abstract method, if I correctly remember, should be this generate here, and then of course you can write here whatever logic you want. Whatever logic you want to generate your UUID. For the moment I will simply let it like that, just generating a random UUID. But again, imagine you need to do something more like sign the value of the primary key using a specific cryptographic algorithm. That's something that if you need, it will not come out of the box with JPA or the JPA implementation, so you need to do that. Okay, so this is it. Yeah, so now I'm going to the employee and I'm gonna use this generic generator value. I need to give it a name, UUID generator for the example, and then I need to specify the type of the class which will become my generator. Previously you would have used this strategy field, now it's deprecated, so now you simply need to do it like this, UUID generator. Observe, this is exactly the class we have implemented here, and then you use the generated value. So we still need to use the generated value annotation, but instead of specifying a strategy like we did here, you will just specify the name of the generator. So this should be enough for us to have provided it with a way of generating the UUIDs, in this case the values in general, in the way we want them to. So we need to test that. Now we want to test this works well. Remember from the last lesson I have taught you how to use the generation of the schema. I have also told you that this is something you should only use it with examples, so remember never to use this with real world applications. I know it looks comfortable, but with real world applications you need to be very much aware of everything that happens in terms of like dropping columns, creating new columns and stuff like that. That's why it's always recommended to disable the automated schema creation with Hibernate and instead use a versioning mechanism for your SQL scripts such as Flyway or Liquibase or something different. These two are the ones that I have used the most, but not this, okay? But for examples, it's okay because we save a lot of time. We don't have to write the DDLs by ourselves. I also enabled the show SQL as you've learned in the previous lesson to see the queries that happen. And let me say employee E1 new employee, and I will set it with a name, so George. I will set it with an address, and then I will not set the ID. No, that's the plan. So we don't give it an identifier. We expect it to be automatically generated. So I use the persist method. Persist, remember, puts the instance in the comments and marks it to be persisted, which means that at the end of the transaction, which is this line 37 in my case, it will most likely in this case be transformed into an insert query. So it will be pushed to the database. That's when Hibernate, our JPA implementation, mirrors the context to the database. So you want here, and then I'm gonna run it and see what happens. So just this, and I'm gonna run it. Go, it has to compile, and once it finished compiling, okay, you can see that the table has been created, and you can also see an insert has been done. Let's see if the table has been indeed created. I will refresh everything, and then I'm selecting the rows, and you can see that the ID, okay, look, the ID has been indeed generated as a UUID. Of course, you'll tell me, hey, but that's already existing. No, you generate UUIDs already using what you told us in the previous lesson. But this is just for you to know that you can actually do the logic yourself. Now, of course, if you really want, I can show you something more complex, such as, for example, you want to like sign the UUID with a cryptographic algorithm. I don't know if this is something realistic. I mean, I don't think I would do that. But let's say you have some kind of legacy system that needs that. What do? Okay, there are things you can't simply do without being able to customize the value. So what if I want to add a signature to this unique identity? I generate it and I sign it with a specific key. Why? Because that's what my system requires. Can I do that? Yes, of course I can do that. So I can just say sign, for example, I get the key value string, primary key value here, and then I need to return somehow the signed value. Now they look like something like, instead of returning this, it will be return sign of this value, no, something like that. And how do I do that? I don't even remember. It's been a lot of time, but I think we can use the simply Java security key pair generator to generate a private key. Normally probably would have it somewhere stocked or something. So this is the key generator, key pair generator, get instance, and let's say that we want to use RSA, and then yeah, definitely you need to use a try catch, and let me do it very simple, just use exception for that, and put this inside my try here. No. And yes, I'm not even sure what I'm doing here. Not sure if I'm doing something that that really makes sense, but I will just prove that you can do that. Yeah, so it shouldn't take me so much time. And say generate key pair. This should provide me a key pair, and then further I should have the private key from the key pair. and then I should have a signature. Signature is signature get instance. I would like to use something like SHA-256 with RSA. Do I have a constant here? Did they finally add a constant for the algorithms? Not really. I just have this. Oh, come on. Okay. Anyway, no problem. There, it's good. It's also this is also good enough. So let me do it back. Put it like this, and then signature. Init signature with the private key. What else should I have done? Get the primary key value bytes and then sign them. And this should provide me with a result, something like that. And then instead of returning here, I would return the, say, primary key value plus a dot plus a base 64 encoded result, something. If I didn't miss anything, then this would be an example of something you can't do directly with any JPA implementation, okay? Maybe it's not realistic, but it's an example of something you can't do otherwise. So let me run it and see if it works, okay? So can we apply base 64 before persisting? Yes, I did that. Okay, so where was it? Sorry, somewhere here. Yeah, I encoded to string and got the result. Oh, and it says data is too long now. The default is 255. Probably it exceeds the default, but you already know how to solve that, don't you? I have told you in the one of the previous lessons that you can use the columnar notation when we have such problems. So when you have to define something specific about the column itself, you use the columnar notation. See, you have a lot of options here, including the possibility to declare it unique, the possibility to make it nullable, insertable, define precision and stuff like that. I know we used it, and I told you it's most often used for the name, but you can use it for any kind of particularity you'd like to set on the column. The same with the table annotation. If you want to set any kind of particularity for the table, you can do that with the table annotation. So in my case, I have no idea how much would I need. I will just use a random 500 here and see if it works. But here it is. Okay, and it seems to have worked now. See, I created a table and the insert was working fine. So let me see what's now in the ID. You can see now the ID is not only it looks like this. Okay, I don't even know where I can show it to you. So let me actually show it to you in Notepad++, something like that. See, it truncated it. Anyway, so it's very large. Okay, so it's very large. I should be able to see it somehow, but it's very large. Anyway, it's the signature after a dot on the UID. This is an example. Okay, I'm not sure if it probably doesn't make sense for a normal application, because you wouldn't want to index on stuff like that. No, imagine the queries, how the queries would be for something like that. But it was an example to show you something you really can't do otherwise. Okay, so now you know, if I have something you really can't do otherwise, you know how to define your own generator, whatever that is. Hopefully that helps. Yeah, with that being said, we already completed one of the most important parts of our example, our demonstration. Now, the second part, as I promised you at the beginning of the lesson, is discussing composed primary keys. So I was telling you, you have situations where you don't have for an entity one value being able to identify them all. You have two or more, so then you have a composite primary, composed primary key. When there's more than one value, you can make a primary key out of multiple values. So that's what I want to show you now. So let's say you have an entity named product, okay? And your product entity, so this is a very simple entity, but you realize that you have something like the business logic of your application has something like a code and maybe something like a number, and then of course you might have whatever else you need, like say a color, and that's it. Just for the sake of the example, I added something more. Let's say that out of these three, the code and the number are the ones that define the unique the unique combination. So you don't necessarily have unique codes and you don't necessarily have unique numbers, but the code and the number as a combination defines uniqueness for your record. In that case, you need to define a composed primary key. There are two ways in which you can define a composed primary key. I will start with the first one, the option with ID class, and then I will show you a second option using embeddable classes. It's called embeddable ID. So yeah, let's see if that works. So what I want to do now, I will create a separate package. I like to be very careful with how I order my types in my code, and you'll never see me putting them all together, even in examples, because that's how I'm used to. Okay, I want to make a very clear structure of my code, and that's what I'm teaching you as well. So let's say I will create some keys type. I create a separate package, and I will create here a class named product key. And the product key class, so what the product key class will have is the combination of code and numbers. So it will basically be nothing more than defining which are the fields that define the primary key. And remember, it should always implement serializable. To be honest with you, I don't know why we still have this restriction, because I don't think it really makes sense a lot today. It made sense in the past, but today I'm not sure if it really makes sense anymore. But the specification says so. So if you want to correctly follow the specification, then implement the serializable marker interface as well. Now, if you have this, you can on the entity say my ID class that defines the composed primary key is product key, and the ID is composed of this field and this field. And remember, the two fields that you mark, or more than two, depending, you might have more than two. No, all the fields, they should have the same name as the fields in the product key class. So I can try it with you. If if you change the name, if the name doesn't correspond, then you will get an error. So Hibernate will not understand, or whatever your JPA implementation is will not understand, will not find the value, and it will not work. See, but the idea is like this. So you have a separate object that defines the key, only the key, and then you use the ID class annotation to mark the entity with the prototype of its key, and then you will be allowed to use the normal ID annotation to define the fields that are part of the key. So that's how it should work. Okay, and then you can go here and you can, let's actually cut this out, the employee, we don't need anymore. You can create a product, but to create a product, you first define the key. Okay, something like that. Sorry, we are on the other example. So you define the product. Okay, and then you set the code ABC, you set the number, then you set or whatever other field you have, and then you persist it. Okay, so what we expect is that the two will become the primary key, they will be a unique combination, and everything will work as expected, no? Even if we don't have one but two fields defining our ID. So let's run it and see if it really works as we expect. Okay, I can see that the table has been created. Let's take a look also on the create table, see what happens. So somewhere here we should see in the definition, in the table definition that has been generated by Hibernate, that the primary key has been declared as being composed from the two columns that we have marked. So expectation, this is our expectation, so it's according to our expectation, so this is what we expected to happen. And then of course an insert seems to have worked as well. So if I'm going here now and refresh my tables, the product appeared. Inside I have my value, and if I want to see the characteristics of this table, I don't know what this error is. Okay, here it is. Somewhere in the indexes you should see that the primary key has been defined from the two columns and is unique. Okay, so it's these two are both of them part of the primary key. So it is as to our expectations. So this is, guys, one of the ways in which you define a composed primary key. If you don't have only one value, you might use it this way. The second approach, but I want to keep both. So I want to keep both of them. So let me create a separate class. I will not override the product. I want to have both approaches in the example, because I will, as you got used to, I will push my example on GitHub after the lesson, and you will be able to take it yourselves and test it yourselves. So that's why I want to add a separate entity here. So it will be probably identical. Let's call it student. And let's say that the student in the university registry is identified by a code and the number. It's exactly the same thing, just that I have a separate entity so that I can keep both examples. Okay, so what can we do in this case? So okay, ID class is an option. Do we have any other option than that? Yes, we do have another option. The second one is have an embedded ID. So what I'm gonna do is I create a student key class. So you see the approach is very similar. I create a separate class, and in the separate class I declare the prototype of the key. So say long number string code. In the same way, so it has to have getters and setters, and it has to implement serializable. But I will use a separate annotation here called embeddable. And this embeddable annotation means that I can plug this type in the entity. So contrary to the way we worked in the previous example where we defined the fields separately, now instead of having the fields, the representation of the key will be by an instance of the key. So that's the second approach, and it's similar but just quite a bit different from this point of view. So you have a separate class, but you define it with embeddable. And then in the student, I don't declare anymore all the fields. I just say private student key ID. I use, and this is also a bit different, you can't use anymore the ID annotation, you have to use the embedded ID annotation, but it's, you see that the error disappears, so it took it correctly as an ID. So basically IntelliJ knows and says, hey, it's correct what you are doing there. And then of course you can have, I don't know, the name of the student, and that's it, and whatever other fields you want, getters and setters. And now you can create a student. To create the student, let me comment this out, so we only work with the student now. To create a student, you first create a key. This is why in the first I started by this. I'm a little bit more used with the embedded ID, but it's not like it comes with very different things. So student key ID, a new student key, and then you set the values ABC, and then you set the number, and then you create the student itself, a student, new student, you set the ID as an instance of type student key, and then you set whatever other values you need, like the name, and then you persist the value. So this is how it looks like. See, you have to create an instance first of the key, and then you create a student, you configure the reference of the instance for the key on the instance, on the entity instance, and then you can persist. Let's run it and see if it correctly happens. Does composite primary key affect the database search performance? From what I know, yes, but that depends a lot on the technology used behind the scenes. So different database management servers work differently. Some are more affected than others. This is not related to JPA or Hibernate or something, is related to the database itself. So whether you use Hibernate or use something else, it will still be affected more or less depending on the vendor you use. But yes, from what I know, using 2 columns or more columns definitely means that the performance is kind of affected. Now, of course, DBMSs are very smart nowadays. They create smart indexes, and but it's still not like even the type of one. If you use a simple key now and use a string versus using one number, is different. The string will be less easy to index than a number by a DBMS. So yes, there will be performance delays there somehow. So it didn't work. It says unable to locate persister. When it says something like that, it means that the entity hasn't been registered as an entity. Remember that we started lessons ago by defining this persistent unit info file, and one of the things you do here is to define the managed classes. So it seems that from other examples I already had the employee and the product and some other value, some other type here, but we didn't have the student, so that's why it doesn't work. We just have to add it here. So you can just add the student here, and then you can run it again and it will work. So let me do that and see the results. Okay, can you create a tutorial on how to use different data sources? Yes, why not? I can do that. Now, different data sources, it really makes a lot of sense to avoid using different data sources, to be honest, but there are situations where we have them and different mechanisms have them, and usually they are segregated, but I will talk it in detail when it comes with that. Okay, I will show you why, how, and when you should work with and when you should avoid data sources. Thank you for your recommendation, Marcin. Okay, it worked fine. So you can see it works in the same way. Look at the queries now. So product uses the first approach, while student uses the second approach, and you can see that the query generated is identical. And of course you can see that also here. If you refresh, you can see that the instance has been stored. If you use the inspector on the student table, you should see something similar to what you have seen for the product as well. So you see it is indeed composed primary key, so it works as expected. So you see it's actually not that difficult after all. Now remember that one thing that I didn't do here, and I want to correct that now because I don't want you to remain with bad habits. When you have composed primary key, it should also mandatory have equals and hash code implemented to define the uniqueness of the fields. So that's not important when persisting. That's why I started with that, and I skipped this detail. But again, I don't want you remember something like this because you will then have problems when trying to use the find or queries. So my recommendation is remember to always define for the keys the equals and the hash code. So let me do that for both our examples here, equals and hash code. I'm using here the straightforward self-generation of IntelliJ, but that's not necessarily what you need to do, okay? You know, you can implement equals and hash code by yourself if you require something more than what IntelliJ can generate for you. And then of course, say I want to put this to none for a bit, and then I'm gonna comment this out and say entity manager find, and that's I want to find the student using its ID, and that's student s. And print it in the console. So you remember the find the find operation with the entity manager, which, as you know, manages the context. Now we know the entity manager is named the manager because it's the manager of the context. You can see here the query that has been selected, and of course I forgot to override the toString, but it actually grabbed. So you see the query automatically has been applied to both fields correctly. This is what we expected, and then a student was a result of that. And yeah, if you want to really see that is your student and not something else, we can override it to string as well, and you will see that. And that's it. Okay, so we managed to prove how to generate primary keys. We know how to use an embedded strategy. We know how to create our own custom generator wherever that's needed. We know how to use composed primary keys. You can't generate composed primary keys. That's a thing. But you can define composed primary keys, and again, with entities, with Hibernate, it's mandatory to have identifiers. So even if you have an old legacy system and your database has tables with no primary keys, if you want to use Hibernate with them, then it's mandatory. See, the student is the one and the student key should have had also the toString, but you can see it's John, it's our student from the database. Okay, so can you record some? Okay, I already read that question. Fine. Then that's everything that I plan to show you today, so I don't want to keep you more. I hope this was an interesting lesson, and thank you very much for being here with me and for your questions. So in the next lesson we will already start discussing relationships. You see that in object relational mapping frameworks, you need to establish relationships among objects, same as you establish relationships among tables. The relationships from your objects will be reflected to the relationships in the database. Practically, you know that, or anyway, you should know because it's a prerequisite for this playlist, but I will make a refresher for you next time. The tables practically can be related as physically only as one-to-one and one-to-many, but logically you can have many-to-many relationships. What you will learn is that objects can have many-to-many relationships as well, so you can really have many-to-many relationships among objects, and they will correctly reflect with a joint table in the database. So that's the discussion we start next time. I doubt we will be able to discuss everything in only one lesson, so probably I will put the 3 kinds of relations in 3 different lessons, but that's what we start discussing next time. So I'm looking forward to your questions, and I'm looking forward to you being here with me again. Until next time we meet, I say again, thank you very much for joining me, guys. I'm waving goodbye, and have an excellent time for studying further. Cheers.